Good evening. Now in third, we are going to see theory and problem on flanged reinforced section. So actually we have T and L, but here we are going to use only T sections. Now here we have actually two types or two categories, one neutral axis in flange. And in this case, we have it will act as rectangular section and in rectangular section, we have to consider B equal to BF, remaining things we have as it is. When DF less than or equal to 3/7 XU, this is one case, means we have DF less than 3/7 XU. So 3/7 we have rectangular section and our DF is less than that of rectangular section. And DF greater than rectangular section means it lies in parabola. So when DF less than 3/7 XU, so we have value of stress, we have rectangular portion in DF, whereas here we have to go for YF. So now we can have neutral axis in flange. So when we have neutral axis in flange, we have diagram in this. We have this as neutral axis. This is XU, D, and this is effective depth. So automatically bottom portion we have D dash. So here I have mentioned it when neutral axis in flange, it will be same as singly reinforced section, replacing B by BF. Now we will equate Cu equal to Tu 0.36 FCK XU BF as 0.87 FY AST. And XU from this we will get 0.87 FY AST upon 0.36 FCK BF. Now from this we are going to get moment of resistance. Same formula which is for rectangular section, but you can see just we have replaced B by BF. Remaining things we have as it is when we have neutral axis in flange. Now we have two cases, neutral axis in wave. First we are going to say DF less than or equal to 3/7 XU. Now you try to understand. So you can see this DF less than or equal to 3/7 XU. So my whole concrete have value of stress as 0.45 FCK. And therefore we have two parts now. We will go with XU, then D, then we have now one part, we have this, which is rectangular part. And that we are going to say as CU1 and its distance that is from neutral, your compression side is D minus 0.42 XU. So CU1 now we have 0.36 FCK XU into BW. This is now rectangular section and we have this as BW. So we have first 0.36 FCK XU into BW. So colors you can see now. Now second, the remaining portion we have that is on compression side. So we have second color. So we have this portion we can say. So these colors you can see. And then we have BF minus BW by 2 and BF minus BW by 2 times. So it will be BF minus BW. And I already mentioned we have stress as 0.45 FCK. So this is stress 0.45 FCK, BF minus BW, this is width and DF is depth. So this is CU2 and which is equal to TU2. Now, sorry, TU, and we know we have this will be 0.87 FY into AST. And this will gives me, from this we are in position to find out value of XU, that is 0.87 FY AST minus 0.45 FCK, BF minus BW into DF upon 0.36 FCK into BW. So now from this MR we are going to find out. Now this is most important. So now how we have this MR. So now you can see this for this MR. We have first CU1 and for CU1 we are going to be D minus 0.42 XU. And for this we have AST1 again. Now second part we have that is of second portion that is CU2. You can see this. So if I will rub actually this portion, then you are in position to see this. So now you can have this CU2. Where it will act? It will act at center of this. Means I have this value. If I will mention, I have DF by 2. Then what will be lever arm? So lever arm is between tensile and compressive force. And this will be D minus DF by 2. Now DF by 2 we have separate and we are in this fashion. And same we have used. This is CU2 And this is my lever arm D minus df by 2. 2 we have only for df, not for whole. And then here we can have AST1, AST2, lever arm we have again same. And likewise, we are in position to calculate MR when we have DF less than or equal to 3/7 of XU. Now in this case, you have to keep in mind my whole concrete in flange that is stress 2.45 FCK. And then we have third case. Now you can see we have third case again, CU1 plus CU2. CU1 we have as it is 0.36 FCK XU BW plus. Then we have second portion BF minus BW. Now what is change? Now you can see if we will go, we have combination, means we have rectangle also and parabola also, and it is difficult to calculate stress in concrete which is below rectangle, and therefore IS code that is given effective depth. And if we will go to the annex G, then annex G page number 97, they have given this value of YF 0.15 XU plus 0.65 DF. Means you can see here. So we are going to convert DF, or we are going to consider YF instead of DF, and we are assuming whole YF portion stressed to 0.45 FCK. And then we are going to be, this will be CU1 same as first part. Only change here, instead of DF, we are going to use YF. And then CU into CU plus 1 plus CU2 equal to 0.87 FIST. Then MR we have now, first part will be as it is, no change in this. Second part in replacing YF, replacing DF by YF. Here also we are replacing DF by YF, because your force CU2 will act at YF by 2, means now we have this as YF by 2. Because we have this distance is YF. And this YF distance or YF portion is traced to 0.45 FCK. And from this we can now find out value of XU, and we can find value of MR. So you can see this. So 0.36 FCK XU BW plus 0.45 FCK BF minus BW. YF we have substituted over here 0.15 XU plus 0.65 DF. And from this we are in position to find out XU. And once we know value of XU, we can find value of MR also. So now we will be with problems in this. So first, this problem is from your question bank. Now we are interested to find the area of steel required. Now student, I have again question, as steel is not given, then how we are going to find out value of area of steel, that is of balance section. But when we will say balance section, so we know we should have XU equal to XU max. And that is equal to 0.48 into D. And that we have to consider, same we have considered over here. So you can see this. So DF actually we have not 130. So we have this as 1300 millimeters. So DF we have 1300 millimeters. 1300. And then this is correct. This is DF. Sorry. So we have this value correct. We have this as DF, depth of flange, not width of flange. Width of flange is 1200. Then we have DF 130, that is depth of slab. BW 275, 2415. Now KU max 0.48. And then we have XU max 116.16 less than 130. This is my depth of slab, or this is my depth of flange. And my depth of flange, this is greater than this. So our whole flange, though our T-beam will act as a rectangular with B equal to BF, and then simply we will go with therefore neutral axis lies in flange, and then we have XU max, because we have to go for balanced, and there we have to use XU max, and from this we will get this value as 2779.73 millimeters square. So this is one type of problem may be asked in examination. Then we have second, we have to find out moment of resistance. So we will go with all three types. One, neutral axis in flange, then neutral axis in wave with DF less than 3/7 of XU, DF greater than 3/7 of XU. So this is first one. Now I will not write given data. In examination you have to write down, because I have given data over here only. So in examination you should go first step, you should have given data, and then you start your steps. So given data, you have to write down all these values. Now we will go 0.36 FCK assuming neutral axis in flange. So we have Cu equal to Tu. Now B is replaced by Bf, and from this we will get value of Xu, which is 94.52. But we have thickness of slab or depth of slab. This is 100 millimeters. So it is in flange only, and then it will act as a rectangular section. So assumption is correct. Neutral axis lies in flange, and it will act as rectangular section with B equal to Bf. Rectangular section, and there we have B equal to Bf. So now you can see this Xu max we have 94.52. Sorry, Xu max we have 240, and 94, which is greater than 94.52 section is under reinforced, and we can find moment of resistance. You can use any formula. You can go with 0.36 FCK Bf into Xu max in bracket, then it will be as it is D minus 0.42 Xu max. From this also you will get same answer. So we have this as moment of resistance. This is first type of problem. Now we will switch over to the second type. So here we have calculate the moment of resistance for a flange section. Same problem. Data we have changed a little, and then we have neutral. Assume neutral axis in flange. Now our assumption is wrong. Now when we will substitute these values, then we have Xu 126.03, which is greater than 100 millimeter. And as it is greater than 100 millimeter, that means my neutral axis lies in web. So assumption is wrong, and neutral axis lies in web. So neutral axis lies in web. And first case we will go DF great less than or equal to 3/7 Xu. Why? Because in that case we have all flange that is traced to 0.45 FCK. And then we will 0.45 FCK Bf minus Bw into Df, and from this we will calculate value of Xu, which will be 129.12 millimeters. Now we will check it 3/7 of Xu. So 3/7 of Xu we have 55.33, and which is less than 100 mm. So our assumption is again wrong because this is not satisfied. So here we can see Df greater than 3/7 of Xu. Now we have this will be last case, and then we will go with assumption is wrong, and now we have last case. We are going to be with Yf, and which is equal to 0.15 Xu plus 0.65 Df. And that we have used. Now this formula we have taken. So if we will go to back, and in back you will see this formula of Xu. So we have this formula you can see over here. So this formula we have used over there. So this you can derive it is very simple. We have taken Xu common from these two. So from this part, and we have from this part. So we have taken Xu common, and due to this it becomes 0.36 FCK Bw plus 0.45 FCK Bf minus Bw into 0.15. And whatever this part, which is 0.45 FCK Bf minus Bw into 0.65 Df, will go on this side, becomes minus. So this becomes minus. And that formula we have used, and we have calculated this value of Xu, and then we have this 166.63 millimeters. And then we have Yf value, which is 90 less than 100 mm. So our assumption is correct now. And then we are going to find out Mr. Now you can see over here, instead of Df, we have to just replace Df by Yf. And then by substituting the value, we are going to get value of Mr, which is 405.39 kilonewton meter. That will gives me value of Mr. And in this case, actually, we are with the third case. Now we will go with one another problem. So with data, little data change. Assume neutral axis in flange, not satisfied. Assumption is wrong. Neutral axis lies in web. So we will go with second assumption. Df less than or equal to 3/7 Xu. You can see we have changes this. Here we have Df, there we have Yf. Now here we have Xu 241.71 millimeters, and now here we have 3/7 Xu. This condition satisfied. Our Df value, this is less than 3/7 of Xu. And now we can go directly with this assumption is correct. And then Xu max under reinforced, and Mr. Now we are going to use Df. and lever arm D minus dF by 2. We will substitute the values, and from this we will get for MR, which is 526.01 kilonewton meter. So we have these three problems only when we will talk about flange sections. And in this actually values of BF are given to you. You need not require to calculate value of BF. Here we have to find only moment of resistance. So go only with this problem more than sufficient. Try to understand it. Once you know how to solve these problems, then like problems like this, you can solve easily in the examination. So thank you.